So we're going to complete these notes. We did arc length yesterday, and we started sector area. Okay, so we got our formula of area equals 1/2 theta r squared, and did 12 and 13 in here, right? Okay, so let's look at 14. So we have our angle, it's in radians, and we have our radius. So do I need to do any converting here? No. So my area is equal to 1/2. What's my theta? 2 pi over 3 times my radius, which is 7 squared. All right, so right here, can I do any reducing? The 2's. So I can cancel these 2's right here. So then I still have to square my 7, which gives me 49. And that's going to give me 49 pi over 3 kilometers squared, because it's area. If you can reduce along the way easier than multiplying it all and reducing in the end. Okay, well, good. So let's look at 15. We are going to change something in 15. I'm going to change that radius to 24. So that means that my area is equal to 1/2. Theta is in radians, so I'm good. 19 pi over 12 times 24 squared. Can I reduce anything right here? Can I cancel the 12 out with the 24? No. The answer to that is no. Why is the answer to that no? Because it's squared. I can't cancel this out, because if these two things cancel that out, then it doesn't make any sense. So be very careful that you're actually reducing at the right spot. But here's what I can do. Remember, we don't want to just multiply for the sake of multiplying. Should we know what 24 squared is? Yes, we should. What is it? 576. Good. But I'm not even going to use that number, even though I know what it is, and I should. In this case, I'm not going to. So this process here, I think, is important for you to see, too. Not for area of a sector, but for anything that comes up like this multiplying, especially when the numbers are bigger. Since I do know that if that was 24, I could do some reducing, right? So the next step, I'm just going to rewrite what I have a little bit differently. I'm going to write this 19, 1/2 times 19 pi over 12 times 24 times 24. Okay? And I'm doing that because now can I reduce some more? Now I can, because the exponent is gone. Well, what's 2 times 12 in the denominator? 24. So those 2 and the 12 cancel one of those 24s, which was way easier than trying to reduce a bigger number. You with me on that? Me writing this out as 1/2 times 2 pi over 3 times 7 times 7 doesn't do me any good. I mean, I kind of can tell if it's going to help me or not when I start, if you can recognize, get what's going on with the numbers. So now I really just have to multiply 24 times 19, and I'm not even going to have a fraction. So I can do 24 times 20 and subtract what? 24. So what's 24 times 20? 480, and I would subtract what? 24, because I only need 19 of them, right? What does that give me? 456 pi meters squared. Everybody good with that? So the formulas are easy. I know you can set things in, but the computation that goes along with it, I promise you, the more you actually do it and practice that, the better you're going to get at it, and the more simple a lot of things you do are going to be. All right, let's look at 16. It says the area of a sector of a circle with a central angle of 240 degrees is 134 feet squared. Find the radius of the circle. So we have area is equal to 1/2 theta r squared. So I didn't make you write the formulas in the other ones, but when you're not just finding the area, it's better to go ahead and write it down so you can put everything right. Did they give me the 134? That's equal to 1/2. Did they give me? Yes, but it's in degrees. Do I get to substitute it 240 right here? No. Okay, so the third, okay? So, and the third quadrant, and that's 240. So what my reference in degrees? That's 240. 60. 80, and that's 60, which is pi thirds, which is really what I want for radians, right? But pi thirds is in the third quadrant. What's your pi thirds angle? pi thirds. This gives you that 4 pi thirds. So that is 4 pi thirds times r squared. Okay, everybody good? You do right now? And the 2, yes, so cancel out that and make that a 2. And I'm going to rewrite this just so I don't lose anybody. So 134 is equal to 2/3 or 2 pi thirds times r squared. So I'd like to get rid of the 2/3. How can I do that? Multiply by 3 halves. Right, so these cancel out. That's the whole reason I did it, right? And then over here, when I multiply 3 halves times 134, I have 3 options. I can take 134, I can multiply it by 3, and then I can divide it by 2. Or I can divide it by 2 and then multiply it by 3. What's the third option? That doesn't require multiplying. What is 3 halves? What's another way to say that? It's 1.5 or 1.5, right? So couldn't I take half of 134 and just put it back to 134? So I get 1/2 of it. Does that make sense? So it's just another option. And so whatever makes the most sense to you is fine, but depending on the number you have in front of you, one way might be way easier than another. Does that make sense to you? Like if I have 100 times 2/3, well, it's going to be 150. I'm sorry, times 3 halves. It's not going to be 150 if it's 2/3, but times 3 halves, it's going to be 150 because I can add half of it to it, right? So same thing here. Like if you wanted whatever makes the most sense. Personally, what I would not do is I wouldn't multiply by 3 and divide by 2 because that just makes my number bigger. But if I divide 134 by 2, what do I get? 67. You can either multiply that by 3 or you can add that to 134. If I add 67 to 134, 134 plus 60 is 194, right? And then I add 7 more, and what do I end up with? 201. So this gives me 201 is equal to pi r squared. I'm trying to get r by itself, so what do I do? Divide by pi. So now I'm going to get r squared is equal to 201 over pi. So then what do I do? Square root. So r equals the square root of 201 over pi. And should this be plus or minus? No. Technically, I get plus or minus, right? The negative doesn't make sense because it's a link. I have a square root in the denominator, so I could rationalize the denominator and get the square root out, but would pi still be in the denominator? Is pi a rational number? No. So you can't get the irrational number in the denominator no matter how hard you try because pi is irrational. And in a situation like this, if you really needed this, you'd be typing this into the calculator at this point, but you need to be able to get here. So we're just going to leave it like this, and it's fine. So we have the in there, and we're done. Okay. Everybody good? All right, so we're going to skip. We're not going to do 17 because it's the picture that it makes the problem very confusing, and so it's just not even worth it. I do want you to look at your assignment because one thing in the front and then multiple things on the back. So on the front, look at number 10. If you've already gotten to number 10, I apologize because I didn't realize that this was an issue until it was too late, and I didn't tell you this. All you're going to change on number 10 is you're going to change, it says the end of minute hand, you're going to change minute to hour. And it says minute twice, so change them both so then it's not even more confusing. If you just change, we're talking about the hour hand instead of the minute hand, the numbers will be a lot smaller. There's a lot more minutes in a day than there are hours, so this won't be bad. All right, we good? On the back, you're changing we're changing one thing on 11 through 17. So I'll scroll if you can see it all, but I'll tell you what they say in case you can't read my handwriting. On number 11, you're changing the radius to 20. 12, you're changing the angle to 240. 13, you're changing the radius to 6. 14, the radius is 7. 15, the angle is 210. 16, the radius is 21. And then I'll scroll it for 17 in a second. But I changed them so that we could leave them in exact form and it wasn't a nightmare. You could have still left them in exact form. It just really wouldn't have been that fun. This way you'll have lots of fun. I'm going to scroll a little bit so you can see the next one. So on 17, I just changed 70.7 to 70 pi. I changed 70.7 to 70 pi. That way the numbers are decent. You'll still get some numerators on the back. I'm just going to go ahead and tell you because it was already a question a couple times last period. But a couple of the numerators on the back, they're bigger. They're not ginormous numbers, but they're, 3 digits. And so some people felt like they might not be doing it right. It's okay. They're not tiny numbers, but they're not horrible, huge, yucky numbers either. Okay. We good? Any questions? All right. So go ahead and glue or tape this in and then make good use of your time and get this done.